Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. So question 6 part A, given that y equals 2 to the power of x and using the result 2 to the power of x equals e to the power x ln 2 or otherwise, show that dy over dx is equal to 2 to the power of x ln 2. So let's see how this is done. Let's get back to the paper and pen. So we have y equals 2 to the power of x, and we have this result that 2 to the power of x, that is equal to e to the power of x ln 2. Now, let's use this result. So if I use this result, I can rewrite this as y is equal to 2 to the power of x. Let's replace that by e to the power x ln 2. And let's work out dy over dx. So dy over dx. So if you're unaware in terms of how to differentiate exponential functions, I've created a video explaining the process and I'll provide a link to this video in the description below. However, if you have a constant in front, so I have 1 in front, 1 is a constant, and in this case we have an exponential function, the derivative will be, for exponential functions, it's the same term, but you need to multiply by the derivative of the power. So the power in this case is x ln 2. So as I say, there is a link to the video in the description below explaining how we differentiate exponential functions. So feel free to take a look. Now d by dx of x ln 2, that being ln 2. And as a result, dy over dx will be ln 2 multiplied by e to the power x ln 2. Now, let's simplify this further. So we can simplify this further because this term, the e to the power of x ln 2, so as a result, e to the power x ln 2 is the same as 2x. So I can rewrite this answer as ln 2 e to the x ln 2 we can replace by 2x, so times 2 to the power of x. Or we can just as well rewrite this answer as 2 to the power of x ln 2 as required. So that completes part A to this question. Let's go back to the question. So part B, find the gradient of the curve with equation y is equal to 2 to the power of x squared at the point with coordinates 2 for x and 16 for y. So let's see how this can be done. Let's go back to the paper and pen. So we have this equation y is equal to 2 to the power of x squared, and we need to work out the gradient of the curve. So let's think about what we need. To work out the gradient, we need the gradient function dy over dx. So before working out the gradient function, here is the trick to differentiate such a term. So first I'm going to take natural logs on both sides. So by taking natural logarithms on both sides. So if I take natural logarithms on both sides, I'll have ln y on the left hand side, that is equal to ln 2 to the power of x squared on the right hand side. Now in the next step, we can use the power rule of logarithms, and if we bring that power to the front, so that's what the power rule is trying to say, I'm going to rewrite this equation as ln y, that is equal to x squared ln 2. Now from here on, remember we need dy over dx, so that is the goal. We need the gradient function for us to work out this gradient at the point 216. So to work out dy over dx, let's differentiate. So now let's differentiate. So by differentiating, in particular, both sides with respect to x. So By this, differentiating with respect to x, I mean we need to work out d by dx, the derivative of the left-hand term, which is ln y. We also need to work out d by dx, the derivative of the right-hand term, x squared ln 2. So let's figure out the derivative, in this case, of the left as well as the right. Now, the derivative of the right is straightforward, but let's think about how we would differentiate the left-hand term. So the left-hand term, let me call that star, and let's do star as a side calculation. So over to the reverse, side calculation, star. So we need to calculate d by dx of, let's remind ourselves, the left-hand term is ln y. So ln y. Now, if you're unaware of how to calculate the derivative of a y term only, I have created a video explaining this, and I'll provide a link to that video in the description below. So let me talk to you briefly about the process. To differentiate any y term with respect to x, first you differentiate that y term only with respect to y. So calculate d by dy of the y term only. Then multiply that by dy over dx. So we're differentiating the y term only using the chain rule. So we're applying the chain rule here. Now, when you differentiate ln y, derivative of ln x is 1 over x, so when you differentiate ln y, it's 1 over y, times dy over dx is 1 over y, dy over dx. So that should be the solution to star. Star is the derivative of the left-hand term. So let's incorporate that in the main step. So for the left-hand term, we had 1 over y, so 1 over y, dy over dx, that is equal to, and when you differentiate x squared ln 2, bearing in mind that ln 2 is a constant, you're going to have 2x ln 2. So on the right hand term, we can write that as 2x ln 2 for when we differentiate that term. Now we need dy over dx, so if we rearrange, dy over dx will be 2xy ln 2. So we can get to this step by multiplying by y both sides. And y is 2 to the power x squared. So since y is 2 to the power of x squared, let's put that into this result. So since y is 2 to the power of x squared, so incorporating that will give us dy over dx, which is 2x ln 2 e to the power, or 2 to the power rather, so 2 to the power x squared. So remember, y is 2 to the power of x squared. I basically replaced the y. So this is the solution for dy over dx. So if we go back to the question, we need the gradient of the curve at the points 2 and 16. So back to the paper and pen. So we have this point 2 and 16. Now let's work out the gradient. So the gradient of the curve at the point 2, 16. So in other words, let's work out m. M denotes gradient. So let's put the x value. So the x value is 2 into our solution for dy over dx. So we have 2 into x, which is 2, ln 2 multiplied by the 2 to the power of x, which is 2 squared. And if we simplify that, m's going to be, now 2 to the power 2 squared, so that's 2 to the power 4, times 2 times another 2, so that's going to give us 64. And we don't forget the ln 2, so it's 64 ln 2. This should be the solution for the gradient of this curve at the point 2, 16. that completes the question, and that sadly ends this video. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.